The third and final factoring type that you're going to have is called factoring simple trinomials. And you know that a trinomial means three terms. So a trinomial is structured as ax squared plus bx plus c. What makes it a simple trinomial is that this a is basically not there. So it's just x squared plus bx plus c. And what you're trying to do is you're trying to find two factors of c, in other words, the number at the end, that will also, meaning it has to be the same two factors, that will also add to b. It has to add to the middle number. And then you set those up in parentheses with the x plus whatever and x plus whatever. It could be minus 2, right? Whatever those two factors are that you find go in that space. Could be plus or it could be minus. Whatever sign needs to happen for that to happen, that's what you do. So that's called factoring simple trinomials. So let's do an example of how that looks like. So if I have something that looks like x squared minus 2x minus 35. Okay, so the way I like to structure it is I like to say, okay, my c value is that last number, which is negative 35. And my b value is the middle number, which is negative 2. Okay, so that's that. So one way that you could structure this is you could create a big X where your C value is up on the top and your B value is at the bottom. Okay, so let's populate that. The C value was negative 35 and the B value was negative 2. And so you're trying to find two numbers here that are going to multiply to make 35, and they're going to add to make negative 2. So they have to multiply to the C value, and it has to add to the negative 2. So what makes 35? You have to know your multiplication tables for this one. Basically, 7 times 5 is 35. And so we write 7 times 5 in here, and you can tell that it has to add to a negative 2. So you have to get your calculator and start playing around and see that 7, if you make the 7 negative, negative 7 plus 5, it will give you a negative 2, and negative 7 times 5 gives you a 35. So that's, sorry, I didn't mean to erase that line. That is basically what you're trying to find. You're trying to find two numbers that multiply to C and add to B. Okay, it has to multiply to this C value, which I'm going to color in yellow, and it has to add to your B value, which I'm going to color in green. Once you find those two numbers, then all you have to do is set it up in parentheses, x minus 7, x plus 5, because the 5 was positive and the x was negative. Sorry, the 5 was positive, the 7 was negative. Sorry about that. Okay, that is what you're doing. What two factors multiply to C and add to B? Let's do another example. All right, let's say I have something that looks like this: x squared plus 7x plus 12. All right, we list out our C value and our B value, so we know we're clear. Our C value here is 12 and our B value is 7, right? C value is 12, B value is 7. You know, we could set this little x up to kind of structure our numbers, we know that the C value was 12 and the B value was 7. They're both positives. So you're trying to figure out what multiplies to make 12 and what adds to make 7. It has to be the same number. Well, what makes 12? If you need to get a multiplication chart, you can. You can, create factors and start to say, well, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Basically, that's what makes 12. You can do that. And then you quickly realize that the only number that will add to 7 is 3 and 4. 3 and 4 are the only numbers that multiply to 12 and add to 7. So those are your answers. So then what you do is you write x plus 3. Oops, sorry. You write the 2 parentheses like we've done before. X plus 3, x plus 4. And so these are your factors of the original problem. What I mean by factors is, again, you're taking a test here pretty soon on multiplying polynomials. If you set an area model with these, you're going to end up getting this, the original answer. So that's what that is. Let's do one more problem as an example, and then I think you should be fine. So the next example is, let's say I have x squared minus x plus 9. Minus is, sorry about that, x squared minus 10x, plus 9. All right, let's see what our C value is and our B value. Our C value is 9 and our B value is negative 10. So we have to figure out what makes these. So let's draw our x so that we could, set up our problem in order. Here's B, C goes on top, that's 9. Negative 10 goes at the bottom. Remember that it has to multiply to this 9 and it has to add to negative 10. And so in this one, you have to be a little bit not creative, but you really have to think about all the factors of 9. Most people say 3 times 3. Yes, 3 times 3 does make 9, but it will never add to 10. So you're like, what other numbers make 9? Well, if 3 times 3 doesn't work, the other things that makes 9 is 1 times 9. 1 times 9 is 9, and if you were to add 1 plus 9, you would get 10. We're trying to get negative 10, and so what happens then is we need to make both of these negative, right? Because if you multiply a negative 1 times a negative 9, you get a positive 9. And if you add a negative 1 plus a negative 9, you get a negative 10. So not only do you have to know your factors, you're going to have to know your positives and negatives. And there's no math trick to this. It's just knowing your multiplication table and knowing how to deal with positives and negatives. So your answer is x minus 1, x minus 9. And that is your answer to that one. So that is it. You're going to have 3 different types of factoring problems to do. You're going to have factoring by GCF, which is greatest common factor, difference of squares, which is a binomial with a subtraction in the middle, and a perfect square. And you're going to have factoring simple trinomials, which is what we just did here. Thanks.